Let's now consider risk in terms of beta. So beta measures the volatility of an individual security against the market as a whole. So in other words, if our beta average is 1, okay, then that's our market average. So when we look at an individual investment or stock and we have a beta that's less than 1, we know it's less riskier than the market versus a beta that's greater than 1 has higher risk. Finally, if there's no beta at all, then it's independent of the market, it's not relevant, and there's no risk whatsoever. And that's considered our risk-free. Now, what's helpful about betas is that we can determine individual stock betas and then find our portfolio base beta by taking a weighted average. Let's take a look. So in this example, Jonathan invested in 4 different stocks, okay, and he invested different amounts in each. And we also know that the stocks have a certain beta. So for instance, stock X's beta is 1.5 versus stock Y's beta is 1.3, so forth. What we need to do is calculate Jonathan's portfolio beta. So we want to understand the overall beta or risk in his all investments. So if we look at his 4 investments here, we see that the different amounts he's invested in, but the total is 150,000. So in order to figure out the percent of how much he's invested in each stock, we divide 25,000, for instance, for X divided by 150. So about 17% of his investment is in stock X, and we know that stock X has a beta of 1.5. So once we figure out the weight or percentage of investments he's made in each stock, we can multiply that by the beta, and ultimately we'll get an average beta or a portfolio beta of all 4 investments. Now, so far we've talked about standard deviation and beta to measure risk. Just a reminder, standard deviation measures all total risk, so that's systematic and unsystematic, where beta just measures the systematic risk. Okay, so if we're looking at a well-diversified portfolio, it's helpful just to take a look at measuring systematic risk. Next aspect is, now that we have an idea between systematic and unsystematic risk, we can use the capital asset pricing model and the security market line to determine the value or the valuation of an asset or an investment. Now, before we take a look at it, we just want to talk about 3 main assumptions. Okay, so the first assumption is that there's a basic reward for weighting the risk-free rate. So what that means is that if we didn't invest at all in any risk, we could still get a return in the risk-free rate. Okay, so we have to assume that there's a value in actually investing. That's why we're taking on a risk, because otherwise we could just not invest. We can invest in, for instance, a treasury bill that has no risk whatsoever. But there's got to be a reason why we're investing. Okay. And also, if we're going to take on more risk, then we should get more reward. Okay, so that's also why we expect to tolerate more risk, because we think that it's going to be worth it. And that trade-off should be consistent. Okay, so it should always be the case that if we have more risk, there's more reward. It shouldn't change at a certain point in time, and it should ultimately be consistent all the way through, and that's what's going to help us graph that line. Okay, so when we use these 3 assumptions, okay, we can actually draw or graph that security market line. And again, we can see, so it starts up here. This is the risk-free rate, okay, and then once we have that, we start at our intercept there. Then we know that, again, that line is consistently going upward. We know that there's a positive correlation between reward and risk. And we understand that the more risk we take on, okay, the more reward or expected return we should be getting. So now there's a very simple equation, just like y equals mx plus b, okay, to graph that line. Okay, and that's what the capital asset pricing model looks like. Okay, and again, we're going to see it here. So imagine that y equals mx plus b that we're more familiar with. Well, the A in this case, okay, is our risk-free rate. So that's where we start our line. Okay, the slope is what's actually going to help us determine the level of risk. So that's going to be our market risk divided or subtracted by our risk-free rate. So in other words, the steeper that slope is, the more risk associated with it. Okay, and beta is our random variable on the x-axis. So we can actually use this equation and plug it in or substitute it to get the capital asset pricing model. And again, we'll discuss more of that when we take a look at our Excel examples. So in this chapter, we've discussed the measurement of the holding period return and its conversion into annualized rates of returns. We've also discussed historical returns and security markets, explaining how we can use standard deviation and variance to calculate the historical risk. Then we discussed future risk by looking at probability distribution frameworks, and we had a discussion about the trade-offs between risk and return. We've also looked at the advantages of diversification, how we can minimize risk. And finally, we discussed the security market line, which is a typical capital asset pricing module that can be developed as a way of quantifying the relationship of an asset's risk and return. Thanks for watching, and happy financing.